Hi dear students, welcome to the next chapter from physics 12th of course. So the next chapter is we are entering to the modern physics area, so which is called dual nature of matter and radiations. Few students I have taken, may not be you may not be comes into that club. For few students I have taken in a different presentation mode, and students are much comfortable with this board, pen and this mode of class. So I thought to re-record this video in that format. Okay, so those who have already attended these classes in the form of presentations can listen to this class once again with this mode of presentation, and those who are new to this, those who are freshly hearing this video, can ignore this, ignore the previous one, the statement whatever I have told. Okay, so this is very clear to you. So we are going to start with a fresh new chapters from modern physics. The first chapter, dual nature of matter and radiations. So please take down the heading, dual nature of matter and radiation. Dual nature of matter and radiation. Dual nature of matter and radiations. Modern physics is an important sessions in the physics area in the 12th standard. Why I am saying it's important in terms of Neet and JE examination or any other entrance examinations where you are writing. So the word itself, you can say it is called modern physics, means latest technologies in the physics we are going to learn deals with these chapters. Okay, so we'll start with the first year mechanics part. There we are learning about a 1D, 2D motion, laws of motion, work power energy, and so many other. These are the old concept. Old concept, it doesn't mean that it is not using now. It is still using. It's still using in many of these mechanical applications. But at the same time, lot of inventions are happening. So these technologies or these things which are emerging in the year of 1900, the things which are happening before, that is before 1900 in the mechanics side, and electric charge, electric field, all other stuffs will be there. But when it comes from here to there, to your semiconductor electronics, the final chapters, till that moment, this is completely the things which are happening after 1900. That's what it is called a modern physics, because it's a latest physics. That is the meaning of this one. Okay, hope this is clear to you. So we'll start with the chapter dual nature of matter and radiation. Dual means what? Dual means two, double, correct? And nature means what? I have a nature, you have a different nature, your friend will have another nature. Nature means your behavior or your character, how you are approaching a person, or how you are communicating with the persons, or what is your real character. That is the nature. So matter, you know, in the entire universe, whatever the things you are seeing in front of you, everything is a matter. You are seeing bench, you are seeing desk, you are seeing laptops, you are you are seeing computers, mobile phone, any gadgets or anything, whatever comes in front of you, it's a matter. So matter is made up of an atom. Atom is the smallest unit. Okay, atom is the smallest unit of any matter. An atom consists of neutrons, proton and electron. So in the sense of matter, here we are comparing with a single atom or electron or proton, any subatomic particles of an atom. Come to the next one, radiation. Radiation is simply, here it is called light. So now we will club all these informations whatever we are getting from dual nature, matter, radiation. Dual nature of, double character of matter, double character of light, means matter will have two characters. Similarly, matter will have, radiation also will have two characters. Okay, so two characters means what are all the two characters are available for this one. So let's talk with this one. First one is I'm taking as for radiation. So in this chapter, the points are very important, because there are numerical questions, sum based questions will be there, but points are there. There are a lot of many small points. Why I am saying like, which of the following statement is wrong, which of the following statement is correct, such a type of theoretical based questions, lot of weightage will be here. So never miss any point whatever I am writing in the board. So radiation is nothing but it is called light. First point. So radiation has two character. In bracket you can write dual nature. So radiations will have two characters. That's my first point. Radiation has two characters. We'll learn about radiations, we'll learn about matter also. So radiations will have two characters. What are the two characters? One is called particle character, particle nature. Initially we told as light is in the form of a particle. So particle nature, particle character or particle nature or particle behavior. Second one is called wave nature. Okay. How the things went in the science is like, whenever when we started to study about light, then it is called optics. Study of light is called optics. We will learn about optics in very detailedly. So first Newton mentioned that Newton's corpuscular theory, this is a first theory, states that Newton's corpuscular theory states that light is having particle nature. So light in a particle nature under the prove it. Or who will be stated? Light is will having the particle nature. Okay. Then science will comes and science will be proved that so this you have learned in the chapter of ray optics. So this is from ray optics. Ray optics is basically concept of a corpuscular theory of lights, and it is based on corpuscular theory of light. But later we will learn about more about the various years also, because that is also important. Later, Young's double slit experiment, at least you may remember this term. Okay, this we will learn very detailedly later. Young's double slit experiment. This is called YDSC, Young's double slit experiment, states that light is having wave nature, not particle nature. So he comes and told that light is not in the form of a particle, light is in the form of a wave. He proved that light is in the form of a wave using an experiment. He proved that light is in the form of a wave nature, states that light is having wave nature, not particle nature. This is what science is going. So this is what is the first behavior. So now it is saying like that. So initially Newton comes and told, okay, as per my corpuscular theory, particle nature. Then after some years we found that no, light is not in the form of a particle, light is in the form of a wave. So we comes to the wave nature of the behavior. But again, as per the modern physics, as per this chapter or as per the modern physics, it is again comes and told like that, no, light is also having particle nature. Light is also having particle nature. So, and this is proved by photoelectric effect. This is proved by photoelectric effect. Okay, so now you can see the beauty of this one. First, when the light is invented or science is started to study about light, first we told light is in the form of a particle nature. Newton told light is in the form of a particle nature using corpuscular theory. Later when science are progressing and after few years, Young's double slit experiments are conducted, and based on the Young's double slit experiment we proved that, oh no, light is not in the form of a particle, light is in the form of a wave. So all are forgot about particle nature. Then science are progressing in 1900s. After 1900s, using Einstein's photoelectric effect. Einstein, this is what we are going to study very detail in this chapter, using Einstein photoelectric effects. And this states that no, light is not only wave nature, light also possesses particle nature. Okay, then science will comes to a conclusion that radiations will have two character. Particle nature is also there, because initial corpuscular theory is an utter fault. Okay, but particle nature is very efficiently proved by Einstein photoelectric effects. Wave nature of light is started to prove by Young's double slit experiment, like interference, diffraction, such phenomena are proved this one. So this is the short points. So hope you understood. From here, Newton corpuscular theory, light is particle, light is in the form of a wave. Again it is saying light is in the form of a particle. So last two statements are acceptable to the science world. Then it is states that light is will have two characters, particle nature as per Newton's photoelectric effects, and wave nature as per interference, diffractions, and Young's double slit experiment. Such phenomena, whatever you are learning in wave optics, it's proved that light is in the form of a wave. We'll learn more about this one. So you will get an intro. Radiations will have two characters, and what are the two characters what we have mentioned. So what is our next part of heading? So then also matter will also have two characters. So we will learn about the matter. Okay, this is a very short intro. You want to understand what is the meaning of heading. That is what I am trying to convey will be here. What is the heading will be states that we are not entering into much into the topic. Okay, so these are the some general informations you must know, so that then only when you are learning about this subject or this chapter, you will able to connect and learn in an efficient way. Okay, so radiation will also have two characters. So now matter will also will have two characters. Matter, next point on it, matter also have two characters, also have two characters, also have two characters. What are the two characters? Again it is saying it also have two characters. One is called particle nature, particle nature. Another one is called wave nature. Okay, so what is called particle nature? Every matter in the universe is made up of a small particles. If you are taking a brick, it is made up of a large number of small particles and clubbed together to form a bigger object. So that is called a particle nature. So this is already we know. So this is a well-known principles to us. So this is a well-known principle. But what is wave nature? Wave nature we will study at the end of the chapter. So wave nature of the matter is proved by Davison's Germer experiment. Davison's Germer experiment proved this. Experiment proved this. Okay, this we will study at the end of the chapter. You don't want to bother about it, but just remember the term Davison-Germer experiment proved the matter will also have wave nature and matter will have particle nature is a very well-known theory to us from our childhood onwards. Every matter in the everything whatever, because in front of me I can see my light systems, I can see my camera, I can see my board, I can see my pen. So everything it is made up of the things. Okay, so everything is made up of one atoms. Okay, so even when I'm standing here on my studio systems, I can see, as I mentioned, I can see everything. The light system is surrounding to me, the board is with me, the camera is with me, mic system is with me, everything is running, and the surrounding echo systems are with me. The noise cancellation system is also there in the studios, and all these are made up of a small particle which is called atoms. That's all. So atoms are matter in a simple way. So that is also have a particle nature, and it also have a wave nature which is proved by Davison's Germer experiment. That is the principle behind over here. Okay. So next we will move to the next area of this one. we are learning more about the photoelectric effect. Okay. So you know the photoelectric effects who proved by? Who proved by? Einstein proved by the photoelectric effect. So this is a bit clear. So we will going to learn more about photoelectric effects. The points whatever I am writing in the board is important. Okay. Okay. So write on the next heading. Photoelectric effect. Photoelectric effect. What is photoelectric effect? First point, when a light of low wavelength, when a light of low wavelength falls on a metal surface, what will happen? When a light of low wavelength falls on a metal surface, what will happen? Electrons are, because matter is made up of atom. Atom will consist of electron, neutron and proton. Electrons are ejected out from the metal surface. What does this means to us? We have a metal surface. You can assume this is a surface. Metal in the surface, so electrons will be here. When a light of low wavelength falls on it, when a light is hit on a metal surfaces, what is going out? Electrons are going out. And this is simply called photoelectric effect. Who proposed this? Einstein proposed this. So Einstein. So remember this word, Einstein. Einstein is proposed this. Photoelectric effects by Einstein. When a light of low wavelength falls on a metal surfaces, the electrons are ejected out. What is a light? Light will have a low wavelength. Light. Low wavelength and frequency and wavelength are opposite, or I can say high frequency. Both are same. High frequency or low wavelength light falls on a metal surfaces, electrons are just ejecting out. This is the basic theory of photoelectric effects. Okay. So this photoelectric effects of light is proved that the light is in the form of a particle. So light is in the form of a particle means if you are checking a chain will have lots of beads are there. Okay, lot of beads will be there. So every beads we can consider like a particle. So all these particles will be clubbed together, will get a form of a chain. Similarly, light will consist of a smaller particle and each of the particles is called photons. Okay, so we are going to write some points. Okay. So photon is what? Particle of light. Light consists of many number of particles. Each of the particle is called photon. Okay. So we'll write the next point by points. Will continue. The particles of light. The particles of light. The particles of light is called photon. The particles of light is called photon. So the name of photon or photons, many number of particles, the particles of light is called photon or energy quanta This is another name. Okay. So particles of the light is called photon, or it is called energy quanta, or it is also called energy packets or quanta energy, anything, energy packet. These are the different names which are used in different books, but all are same. Particles of light is called photon. So light is consist of large number of particles. So each of the particle is called photon, 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 photon. All the photons together will get a group of photons, and these photons together it is called in the form of a light. Okay. The mass of the photon, next point, the mass of the photon can't be defined. How much is the mass we cannot say, but one thing we can say, the rest mass of photon is equal to 0. The rest mass of photon is equal to 0. A photon will always travel, means light. A photon always travel. What is the speed? Always travel with a speed of 3 into 10 power 8 meter per second. Okay, that is the speed of light, right? Photon is traveled with a speed of 3 into 10 power 8 meter per second. Okay. What is the so mass of the proton is defined and the speed is defined. A photon is chargeless. A photon has no charge. Hence it is not deviated by. Electric field and magnetic field. You can write it as a sentence or you can write it as E and B. Hence it is not deviated by. If it has a charge only, it has some effect. So this is a chargeless thing and it has no charge. So photon, I can say it's a neutral body. So a photon I had written as phone. A photon. Okay. A photon has no charge because it's a neutral, hence it is not deviated by. Electric field and magnetic field is not affecting this photon because it's completely chargeless, which has no charges are involved on this one. Okay, next one. I need some space. So hope you have noted all these points. As I told, the points are very important in these chapters, because based on this only the things are running. Fine. Okay. Fine. Each photon have a definite energy. Each photon have a definite energy. And the energy E is equal to hc by lambda. We know from the standard equation C is equal to F lambda, velocity. So E is equal to C by lambda is equal to F. So you can write it as HF. So, okay, and also each photons will have a definite energy and definite momentum. So add this, and definite momentum. So each photons will have definite energy and definite momentum. So energy will have two equations I have written here. Similarly, the momentum P is equal to, and the momentum equation P is equal to h by lambda is called the momentum. This is a momentum equation. By combining these two, h by lambda I can substitute P. So I can say E is equal to PC. So these are the different equations. So there are three equations for energy. E is equal to hc by lambda, C by lambda is called hf, and E is equal to h by lambda is called Pz. What is called h? H is called Planck's constant. And the value of H is equal to 6.632 into 10 power minus 34 joule second. And C is equal to 3 into 10 power 8 meter per second. And lambda is the wavelength of light or photon. Light means collection of photons. And F means frequency. F means frequency of photon. So frequency of photon and wavelength of photon. Okay, hope this is clear. We have a collection of equations and we have a collection of terms. So Planck's constant important. Okay, so here H is called the Planck's constant, and the Planck's constant will normally asking as a dimension formula of Planck's constant. So if you see, will be here E is equal to H nu. H is equal to energy by F. Energy by F. So energy by F means what? The frequency in the dimension formula. So we are going to learn one more additional stuff will be here. Okay, so hope this is it's clear to you. So I need to add one more point will be here to make it clear. Okay, so I am writing dimensional formula of the next point. We don't know where we'll get one question, so we have to write all the points. Dimensional formula of H, of Planck's constant. We know E is equal to HF and H is equal to E by F. So E in the unit joule, frequency in the unit is second raised to -1. So if it comes to numerator, it become S. So we are going to find out the dimension formula of H. Dimension formula is joule second. Joule means energy. Energy in the dimension formula ml square T power -2. Okay, this we can derive it from the equation work is equal to F into S. Force in the dimension formula, mass into acceleration. Mass into accelerations, you know. F in the formula, S in the formula, meter. From this one you can find the formula for work or joule energy. Already we have seen in the dimension analysis chapter. So I have directly written the energy in the dimension formula into second. Second means what? Second means time t. So formula will becomes as ml square T power -1. So this is a dimension formula of the Planck's constant. So these are important. Okay, I would like to add one more points to make it as an energy formula in a simple and a precise way. Depends upon for to solve certain questions. If when you able to solve this questions, you know E is equal to the next point. E is equal to HC by lambda. Okay, so H in the value 6.632 into 10 power -34 and C in the value 3 into 10 power of 8 whole divided by lambda. If such cases are given to you, so the value of energy, if question is asking you want to find out the value of energy in electron volt, then if you solve this numerator you will get 1240. But remember that the lambda in the question, it is given in terms of nanometer. This is very important. We'll use it solve the problem. Suppose they will ask you question, a light of yellow light of wavelength 600 nanometer is given to you or hitting on a metal surfaces. What is the energy within the radiation? Within the radiation means what is the energy of that light? What is the light we are using? We are using maybe some yellow light for example, and which will have some 800 nanometer. If question is saying yellow light 800 nanometer, so you have to substitute will be 800 as such. Don't need to convert into meter because it's saying nanometer. You substitute the nanometer value and you will get one value of energy, and that value of energy is in electron volt. Your answer is in electron volt, not in joule. Suppose if you want to convert electron volt into joule, very important. Suppose you want to convert electron volt into joule, you have to multiply it with 1.6 into 10 power -19 electronic charge which I multiply. Then you will get the energy in terms of joule. So again I am repeating, lambda is a in terms of nanometer given in the question. You substitute exactly like this. You will get an energy equations in terms of electron volt. That is the concept will be here. Okay, so fine. Okay, so I am going to the next points will be here. Okay, and the energy of the photon or as well as the momentum of the photon is depends upon the wavelength or the frequency. Wavelength and frequency are the reversible proportions, right? Okay, so I can say photon energy and momentum. Energy is called E, momentum is called P. Depends only on lambda. For example, we know E is equal to hc by lambda, P is equal to h by lambda. So I can say if lambda is constant, E and P is constant. E and P is constant. If lambda is constant, E and P is constant. Okay, next point. I would like to add the next point over here. Okay, so what is the next point? Next point is the collision of electrons with metal surface is elastic. We are assuming it is as elastic to make our calculation easier, nothing else. So the collision of electrons with the metal surface is elastic. The collision of, not the electron, the collision of photons. The collision of photons with the metal. Photons are hitting on a metal surface, so what is coming out? Electrons are coming out. It's elastic. Elastic means what? Initial momentum is equal to final momentum. Initial energy is equal to final energy. This is what is the principles of collision if it is an elastic collision. Okay, the collision of photons with the metal surface is, you can say it is perfectly elastic. It is perfectly elastic. Then initial momentum is equal to the final momentum. So this has to be remembered. Okay. Next one. Next point. Next point. If the intensity of the light increases, only number of photons increases. No change in energy. For example, let me consider like an example. So suppose I have one bulb. Okay, suppose I have one bulb will be here. Okay, I have the second bulb. So the first bulb is, I am assuming, let's say it's a 50 watt. Second bulb I am assuming it is a 100 watt. So what will happen? What is the difference between 50 watt and 100 watt? 100 watt is more intensity. Light will be there. If more intensity will be there, the electrons which are, or not the electron, the photons which are come down is having high count. But the photons which are coming out from a 50 watt bulb is lesser, are comparable to the 100 watt bulb, because here intensity, more intensity means more number of photons. So here what? Less number of photons. So energy is normally we are calculating for a photon. So energy, suppose we are assuming this is a yellow light, so wavelength is constant. This is also yellow light. So with respect to this, by comparing this one, what is same? Lambda same are, because lambda is depends only on the color. Power is changing, means intensity is changing. When intensity is changing, number of photons are changing. But energy of a photon, here E is equal to hc by lambda. In this case also, so here also energy is equal to hc by lambda. So which means E is constant. Energy is constant. Energy is not changing. Energy between these two and these two are same. Intensity increases means number of photons which are coming out of the bulb will be getting changes based upon the power. Okay, more power bulb irukkumbodhu more will be, this is the cases. Okay, fine. Okay, perfect. So now we know when a light of intensity certain falls on a metal surfaces, electrons are projected out or electrons are come out. Fine, perfect. Next, we are moving to the next area of this one, and which is called the work functions. So please write on the next heading, emission of electron from a metal surfaces. So you can write the heading, emission of electrons from a metal surface. Emission of electron from a metal surface. So this is related with a term called work function. This is related with a term called work functions, which is called phi. So emission of electron from a metal surface, and this is related with a term called work functions. Electrons on the metal surface. Okay, so first point, the electrons on the metal surface, metal veliyil irukana. So electrons on the metal surface is less bounded compared to electrons inside the matter or inside the metal. What I'm trying to say means, in the surface of a metal will contains an electrons, the electrons in the metal surfaces, and the electrons in the metal surface is called what? Is called free electrons, or you also called as valence electron in chemistry, free electrons. These are because we know in case of an atom, central nucleus, and here we have orbit, here we have orbit. So this electrons, which electron will having the highest energy? The outer electrons, like I am giving 1, 2, 3. So the third electrons will have the highest energy, and it is away from the orbit, and it is less bounded to the nucleus. So if I am giving certain amount of energy into the atom, it is very easy to take this electron out. Electron number 1, it is very easy to take out because it is a valence electron or it is a free electron. Okay, then if I am giving much more energy, I can take electron number 2. If I am giving again more energy, I can take electron number 3. But if I am giving a small energy, electron number 1 is the easy way to take it out of this one. This is called free electron, or this is called the surface electron. Okay, so this is called the free electron, or this is also called surface electron. This is also called surface electron. This is also called surface electron. Okay. So electrons which are on the surface of a metal surface, if it is a metal block, electrons will be there spreaded on the surface, which are less bounded to that. But electrons inside the metals are very tightly coupled with the nucleus. So surface electrons are very easy to take it out, very easy to pull it out. Okay, so this was the process. So electrons on the metal surface is less bounded compared to the electrons inside the metal. Electrons in the metal surface is called free electron or the surface electron. So there are, next one, there are three ways to take out the surface electrons. There are three ways to take out the surface electron. To take out the surface electron, there are three methods are there, or three options are there. What are the three options? That's what we are going to see as next. Okay. So there are three methods are there to take out the electron in the metal surfaces. So we'll see the three methods. Okay. Next point, next 3 points, we will also describe these three methods. The next point and the first method. Next point, the first method is called thermionic emission. Is called thermionic emission. Okay. So what we are giving will be here, by heating the metal surface, by heating the metal surface, electrons can take out. Electrons can take out. Electrons can take out, which means if a metal surface will be here and electrons will be here, I am giving heat energy into this metal, heat energy. If I am giving heat energy, thermionic emission. Thermal means what? Temperature. So if I am giving heat energy, if a sufficient heat energies are given to the metal surfaces, the electrons are going out, and that process is called a thermionic emission. Next one is called field emission. Field emission. Field emission. So what is called field emissions? By giving so we are giving what? By giving electric field, by giving electric field to the metal surface, to the metal surface, electrons can take out. Electrons can take out, which means that what? I have an area which contains electric field, plus plate, minus plate. So an electric field will be here. Here I placed one metal plate. Here this contains electric field. So because of this electric field, because of the high electric field, electrons are coming out, and this process is called field emission. So thermionic emission because of heat, field emission is because of the electric field. And there are one more thing. So two things are over, and the third thing is called photoelectric effect. This is what we are more interested. Photoelectric effect. Photoelectric effects means what? What is a photoelectric effect, sir? Photoelectric effect means what? By giving light energy to metal, by giving light energy to metal, electrons can take out, by giving energy into this electrons, by giving light energy to the metal, electrons can take out, which means that what? I have a metal surfaces. For the metal surfaces, I am giving an light energy. So I am giving light. If I am giving light, what will happen? Because of the low wavelength, high frequency lights, if I am giving, this electrons are take it out, and this process is called photoelectric effect. So I have three methods to take the electrons out of the metal surfaces. So there are three methods: thermionic emission because of heat energy, field emission because of electric field, and photoelectric effects by giving the light energy of a metals with by giving a light energy to the metal, electrons can be plucked out. So three method of emission of electron from a metal surface. I will come to work functions. It is there, it's there on the track, but these are the three methods of getting the field emission. Hope this session is clear to you. This we are entering into the topic and we learn few terms. As I told, a lot of theoretical points will be there. Everything should be there on your notebook. Okay. Thanks for watching the video for today, and we'll see the continuation of this topic in the next sessions.